Hey, what's up, everybody? This is Church of the Enlightened, and I'm your minister, Erskine Gibson. And today, this video is going to be called, I'm going to explain exactly what the universe is, how it works, and what the chances are that there's other life in the universe. So in this video, I'm going to tie together everything I talked about in my last two videos. I'm going to give you the complete picture of the universe, how it works, and what is the chance that there is other life other than us in this universe. So the first thing I want to do is talk about our solar system. In the last videos, I talked about how our solar system is an atom. If you know anything about an atom or atomic structure, you should know that our solar system is a direct representation of an atom. The sun is the protons and the neutrons, and the planets are the electrons. Now, I also explained what type of atom our solar system is. How many planets are in the solar system? 8. Which atom has 8 electrons? The oxygen atom. Our solar system is one gigantic oxygen atom. Now, so that means that every star that we see that has planets revolving around it, all of those solar systems are atoms. That's what they are. And the way we can tell what kind of atom it is by how many planets are revolving around the sun. The number of planets will tell us the number of electrons and what kind of atom it is. Now, scientists have said there are trillions of stars in our universe. I'm going to give you a more approximate number. I'm going to say there are 100 trillion stars approximately in our universe. How do I know that? Because I know that there are 100 trillion atoms in a cell. So if there are 100 trillion atoms in a cell and all of the stars are atoms, what does that make our universe? Our universe is a cell. It is a biological cell. Now, you know, a lot of y'all think the universe is this mystical, magical place, but all it is in reality is a cell. That's what it is. Now, in the beginning, I said the universe was a living organism. I was wrong. The universe is just one cell that's part of a living organism. Now, scientists have talked about the Big Bang. So what actually happened 13 or 14 billion years ago was that a cell came into existence. Now, it may have been part of a bunch of other cells, you know, maybe a baby was born or something like that. But our cell came into existence about 13 or 14 billion years ago. Now, I know a lot of y'all are going to have trouble understanding how our universe could be a cell and how our solar system could be an atom, considering how small these things are as we know them. So what I'm going to have to explain next to y'all is going to be really hard for a lot of y'all to understand and grasp, but you have to for any of the rest of this to make sense to you. So let me explain that we are incredibly, incredibly tiny as it compares to the universe. We are so small that we are almost non-existent. There is not even a measurement to measure how small we are, you know, within the scale of the universe. So let me put it like this. If an atom is as big as a solar system to us, that should tell you how small we really are. Now, if you know anything, once again, excuse me, about atomic structure, you know that atoms are the smallest measurement of matter that we know of. There is no smaller measurement of matter than an atom. Now, the only things we know of that are smaller than an atom are the subatomic particles that make up the atom, like the neutrons, electrons, and protons, and something that's called a quark. A quark is supposed to be smaller than the subatomic particles. Now, if you look at our solar system, what would be considered a quark would be like the moons. The moons are significantly smaller than the subatomic particles, being the sun and the planets. But if you compare the moons to us, the moons are quite massive. That means we, as human beings, are significantly smaller than quarks. That means we are significantly smaller than the smallest known measurement that we know of. That means that if we were this organism trying to measure us, it would have no way to measure how small we are. Now, that should tell scientists something. Scientists say that the atom is the smallest measurement of matter. It obviously is not. There obviously are much things smaller than an atom as it relates to matter, and we are the living proof of that. We are the living proof that that there are things much, much smaller than atoms. Now, keep in mind, not only are we much smaller than the atom, but there are things that are much smaller than us. So if you even compare that to the universe, like I said, there are measurements that go backwards towards the small and that are beyond our conception. In the same way, you know, as we go forward and look at how big the universe really is, that's also beyond our conception. But the point I'm making is, we are so small as it relates to this universe. That's why a solar system would, or why an atom is as big as a solar system to us, and why a cell makes up our entire universe. Just a cell. Now, I want to talk about something else. I want to talk about the star that's closest to our star, or the solar system that's closest to our solar system, and it's called Alpha Centauri. Alpha Centauri is actually 3 solar systems connected together. Now, if the solar systems are atoms, and actually, you know, let me show you a picture. I wanted to show you a picture of our solar system. I want to show you a picture of what an oxygen atom looks like, so you can see how it looks. The first picture is exactly how our solar system looks. That's exactly how the planets revolve around the sun. That's how it really looks. Now, I also have another picture where I'm going to show you how the like this is not how it really looks, but this is still another representation of an oxygen atom and our solar system. So if you look at the first 2 electrons, that would be Jupiter and Saturn. The next 2 electrons would be Uranus and Neptune. And then the next 2 would be Earth and Venus. And then you got Mars and Mercury, of course, doing their thing. But this is how our solar system is an atom. This atom looks exactly like our solar system. Or these atoms look exactly like our solar system. But anyway, back to Alpha Centauri. Since Alpha Centauri is 3 solar systems together, that means they are 3 atoms together. What do 3 atoms make? 3 atoms make a molecule. Now, I am going to make a prediction right now. Me, Minister Erskine Gibson, the first person ever to make this prediction, I am going to predict that Alpha Centauri is actually a water molecule. And I'm going to further predict that Alpha Centauri A and B are both hydrogen atoms, and Proxima Centauri is an oxygen atom. Remember that I am the one who predicted that. So when they have to change the history books and the science books, and they will, believe me, I'm telling you, they will, my name should be the one in there as the person who predicted what these solar systems actually were. The first person to do it. So, Alpha Centauri is a water molecule. That's what it is. And like I said, Alpha Centauri A and B, those solar systems are hydrogen atoms. And I'm gonna get back to, and Proxima Centauri is the oxygen atom. And I'm gonna talk more about Alpha Centauri. Alpha Centauri is very significant, and I'm actually gonna predict in a little bit how many planets revolve around Proxima Centauri and how many planets revolve around Alpha Centauri A and B. But before I do that, I want to talk about something else. I want to talk about the galaxies and what the galaxies actually are. You know, those millions and billions of stars that we see clustered together. What are the galaxies? Let me explain. Since we know that these solar systems are actually atoms, when atoms come together, they form molecules. What these galaxies actually are molecules strung together. And what they form are proteins. The galaxies are the proteins that exist within the cell. Now I'm going to show you another picture. I'm going to show you a picture of what proteins look like in a cell. Now, if you look at this picture, you see that these proteins look exactly what our galaxies look like. So our galaxies are the proteins that exist within the cells. Even our own Milky Way galaxy is a protein. And just so you know, our solar system is connected to these other systems. Now, I don't know what they're connected to and how they're connected, but they're definitely connected to the other systems because, like I said, proteins are made of molecules and molecules are made of atoms. The next thing I want to talk about are the black holes. What are the black holes? Now, I don't fully understand what the black holes, but I do understand this much. I can tell you this is one thing that they do for certain. They remove the toxins out of the cell. What that means is they remove the toxic molecules from the cell. Molecules are atoms. Atoms are the solar systems. So the black holes remove the toxic atoms or solar systems from the cell. That's how they remove the toxins. That's what the black holes do, at least one of their functions. Okay, now on to the good part. On to the part a lot of you probably have been waiting for. Is there any life in this universe besides us? And if there is, how much? Excuse me. Before I talk about that, though, before I talk about life, let's talk about Earth for a minute. And let's talk about what the driving force for life is on Earth. What's the most important building block of life on this planet? What's the most important thing to our survival? All life, all carbon-based life. It is oxygen. Every single living organism, every single carbon-based living organism on this planet needs oxygen to survive. We literally couldn't go but a few minutes without oxygen or we would die. That's the majority of life forms. Now, some of you may be thinking, hey, what about the trees? The trees don't need oxygen. Yes, the trees do need oxygen. The trees take in carbon dioxide, which is one atom of carbon and two atoms of oxygen. Carbon dioxide is one atom carbon and two atoms oxygen. So even the trees need oxygen. Every single living thing on this planet needs oxygen to survive. Everything, with no exception. So if we're going to look for other life in the universe, what should we be looking for? We should be looking for oxygen. So now I need y'all to put on your biology hats for a minute. Okay, I said that this universe is a cell, and I'm 100% certain that our universe is a cell. Which also means, by the way, that we are inside of a living organism, as I first predicted, because a cell has to be part of a living organism. But anyway, a cell is typically made up of 70% water. Now, we know that oxygen is 1/3 of water. So, oxygen in this case would be 23.33% of the water that exists in the universe, of the 70% of the water that exists in the universe. So that means our universe is made up of 23.33% oxygen. That means that our universe is made up of solar systems just like ours, or ones very similar to it. 23% of the universe. That's over 1/5 of the universe. That is freaking huge if you think about it. That's crazy. That's enormous. That's a lot of life. Now, understand, all you need for life is a planet that has liquid water, an electromagnetic field, and oxygen in the atmosphere. Now, the reason why I say liquid water, because that also includes the temperature, because for it to be liquid, the planet has to be a certain temperature. So anywhere that those conditions exist, there is going to be life. Any solar system like ours, meaning a sun with 8 planets revolving around it, and one of those planets has liquid water, an electromagnetic field, and oxygen, there is going to be life in that solar system. Now, let's think back to what I said about Alpha Centauri. I said I was coming back to it. Now, Alpha Centauri, which contains Proxima Centauri, is the closest star or the closest solar system to our solar system. So, remember I said that Alpha Centauri is made up of 2 hydrogen atoms and 1 oxygen atom. That means that not only is there other life in the universe, there is life right next to us in the very next solar system. Proxima Centauri, to be more specific, the planet would be Proxima Centauri B. Now, if you think I'm making this up or I'm pulling this out of my ass, just Google Proxima Centauri. Scientists also believe that the conditions in this solar system, that there are conditions in this solar system, that possible life could be there. The scientists believe that. They just don't know the why and the how. They just predict that it's there based on the conditions that they know. I just gave you the why and the how of why life is going to exist on Proxima Centauri, and more specifically Proxima Centauri B, the Earth-like planet. Now, I said that I was going to make another prediction regarding how many planets the 3 stars in Alpha Centauri have revolving around them. So, Minister Erskine Gibson is going to make yet one more prediction. This should end up in the history books. Proxima Centauri has 8 planets revolving around it like our solar system does, just like ours. Alpha Centauri A and B each have 1 planet revolving around them. How do I know that? Because I know that a hydrogen atom only has 1 electron. So that means that Alpha Centauri A and B are both only going to have 1 planet revolving around them. So, scientists, when you see all of these stars float through the universe that only has 1 planet around orbiting them, those are hydrogen atoms. So if we see a hydrogen atom, there's a very good chance that we'll see another hydrogen atom and an oxygen atom somewhere close by. Now, one thing I do have to mention, I do have to be totally straight about the science here. There is a difference between our solar system and Proxima Centauri. The Proxima Centauri is a red dwarf star, and we know our star is a yellow star. So, while I'm quite confident that there will be life on Proxima Centauri B, provided some type of, cataclysm didn't wipe it out, there could be a difference in the types of life. Because understand, even though Proxima Centauri and our solar system are both oxygen atoms, they're different types of oxygen atoms. They're not the same oxygen atom. So, the life that exists on Proxima Centauri B may not be the same life that we see here on this planet. It may be different. There may not be any intelligent humans. God knows what kind of life it may be, but there will be some form of life, that I can guarantee you. I just don't know what kind, because of the stars being different. I don't know if different energy would impact the life forms. I would assume it probably would, but we really have no way to know that as of yet. But I will one day, I promise you that. I will one day. So anyway, y'all, I'm going to go ahead and get ready to wrap it up. Let's see. I've explained what our solar systems are, that our solar system is an oxygen atom. The reason why it's so big to us is because we're so small. We're significantly smaller than a quark, the smallest unit of measurement that we know. We are significantly small. Now, just something else that you should know is that even though there's life, or more than likely life, in over 20% of the universe, the chances that we would ever be able to meet is very, very slim. Understand that it would take us 75,000 years to make it to Proxima Centauri. 75,000 years. If we were traveling at the speed of the Voyager, that probe is out in space right now. If we were traveling at that speed, it would take us 75,000 years. I think if we were traveling at the speed of light, it would take us about 8,000 years, which is still a long time just to get to the next star. You know, we're talking tremendous distances. And not even just that, because also the life on these other planets are also significantly smaller than quarks. You know, they're going to be in the same predicament as us. You know, it's going to take forever to go anywhere because we're so small. Now, something else I want to mention. There are 100 trillion cells in the human body. So if the organism that our universe is part of is something like us, we're talking 100 trillion other universes, which is quite astounding when you think about that. The last thing I want to say is that for us to truly understand this universe, we're going to have to truly understand what's happening inside of us. In order for us to truly what's happening inside of us, we're going to have to truly understand the universe. We are connected. Now, if you think about it, based on everything I've told you, we can look at our solar system and see exactly how an atom functions and operates. We can see it right up close. Everything that's involved in atomic structure. You know what I'm saying? The things I've said, I promise, I guarantee, will be proven accurate and correct. And once they are, the whole face of science will be changed. Everything that we think we've known up to this point is going to change, because I've laid the groundwork for it to change. And like I said, I expect to see my name's in the history books one of these days. I promise you, it's going to happen. It may not happen while I'm alive. I hope it does. But if it doesn't, as long as my kids or their kids get the credit, cool with me. I know some of y'all might be wondering, how does that guy with the Nike hat and the sunglasses and the Seal of Metatron and the Seal of Solomon and the mathematical tattoos on his arms and the symbols on his hands, how does this guy know so much? How does he know so much about astronomy? How does he know so much about chemistry? How does he know so much about biology? How does he know so much about the universe? Who is this guy? Who am I indeed? Well, I'm going to let y'all figure out who I am, but I will say this. I am the minister Erskine Gibson, and I'm representing Church of the Enlightened. I hope that you were able to enjoy and learn something from this video. Thank you for watching the video. I love you all. Everybody, please stay safe, stay strong, stay healthy. Peace.